Welcome to chemistry classes. In this video we are going to discuss about coordination compounds part 2. Here we have to discuss here coordination compounds, and here we will discuss nomenclature of coordination compounds, how to write different names of coordination compound, and how to write the formula of coordination compound. Also we will discuss here isomerism in coordination compound. We will discuss here isomerism in coordination compound. So let us check here. First we have to check here rules to write formula of coordination compound. We have to check here different rules to write formula of coordination compound. Okay, so look here, there are some rules. No need to memorize these rules, you just understand the rules to write formula of coordination compound. Here first one, when we are writing the formula, these are the formula of coordination compound. When you are writing this type of formula, you have to follow this rule. Okay, first one, we have to write central metal atom. Okay, central metal atom listed first. We have to write central metal atom first. Here chromium first, here cobalt first. Okay, so central metal atom list first. Okay, and here second one, we have to check, we have to arrange ligands according to their alphabetic order. Okay, sometime coordination compound contain more than one ligand. So you have to arrange these ligands according to their alphabetic order. Okay, so look here first one, here this is one coordination compound, here central metal atom, and there is two ligand, NH3 and H2O. Okay, NH3, it is amine, and H2O, aqua. Okay, so here NH3, it will be written like this, amine, and H2O, it is aqua, amine and aqua. So look here, when you are checking this alphabetic order, amine, you have to write amine first, then aqua. Okay, if there is more than one ligand, you have to arrange ligands according to their alphabetic order. Clear? Next one, we have to check here. Sometimes ligands, it contain abbreviation. Okay, for example, ethylene diamine. Okay, PPH, like this abbreviation, PPH tries. Okay, so triphenyl phosphate, this type of abbreviation. If there is abbreviation in ligands, also these ligands are arranging according to their alphabetic order. Okay, here ligands are arranging according to their alphabetic order, and it does not depends on the charge of ligands. Okay, sometimes ligands -1, -2, okay, they have different charge. Ligands are not arranging according to their charge. Okay, arrangement of ligands only depends on their alphabetic order. Clear? Okay, next one, here we have to understand here entire coordination entity. Here coordination, here ligands and central metal atom. Okay, they are enclosed in a square bracket. Okay, here central metal atom and ligands are enclosed in a square bracket. Okay, and we discussed before, this part is called coordination entity. This coordination entity, it is enclosed in a square bracket with or without charge. With or without charge means some ligands they have charge, some ligands they do not have charge. Okay, whatever, here central metal atom and ligands, we have to write it, or we have to include this in a square bracket. Okay, and I told you sometimes they have charge. Okay, this charge we have to write outside square bracket here. on the top side of outside the square bracket. Okay, top right hand side we will mark their charge. Clear? Also here last point we have to understand here, the charge of cation and anion will be balanced. Okay, here a coordination compound, they have positively charged part and negatively charged part. Okay, positively charged part it is cationic part, negatively charged part it is anionic part. Okay, always negatively charged part and positively charged part will be balanced. Clear? You know ionic compound, in ionic compound sodium chloride it is ionic compound, sodium positive charge, chlorine it is negative charge. So you know in ionic compound always positively charged part and negatively charged part will be balanced always. Okay, you can check another example, magnesium oxide Mg2 plus O2 minus. So positive charge and negative charge will be balanced. Similarly here in coordination compound positively charged part and negatively charged part will be balanced. Okay, so these are the rules for writing coordination compound. Simply you understand we have to write central metal atom first. Okay, then ligands we have to arrange according to their alphabetic order. Coordination entity, this is coordination entity, it must be in a square bracket. If there is any charge we have to write right hand side, top right hand side. Clear? So these are the things you have to remember to write formula of a coordination compound. Okay, next one we have to discuss here rules for writing name of coordination compound. The previous one we discussed rules for writing formula of coordination compound. Formula for coordination compound rules we discussed. Next one we have to write, we have formula. From formula we have to write name. Okay, from formula we have to write name. Okay, this situation also we have to follow some rules. Okay, so these are the rules to follow to write name of coordination compound. So let us check here. Look here, when you are writing formula of coordination compound, when you are writing name of coordination compound, you have to name cations. Cation part you have to write first. Okay, some situation you have coordination compound. Okay, coordination compound, there will be two coordination entity. Sometimes you have two coordination entity, or sometimes you have coordination compound, there is positive part and negative part, there is cation part and anion part. So you have to name cation part, you have to name first. Okay, so this is the first rule, cation part we have to name first. Here second one ligands, we have to name ligands according to their alphabetic order. The previous one also we discussed, when you are writing formula you have to write according to alphabetic order. Here also when we are writing name of coordination compound we have to name ligands according to their alphabetic order. For example, look here, these are two ligands NH3 and H2O. NH3 it is amine, H2O aqua, H2O it is ligand and it named like this aqua, this is amine. So amine we have to write first, amine we have to write first because the letters are coming AM, here aqua AQ. So alphabetic order we have to say AM first, amine first, then aqua. Clear? So here ligands are named according to their alphabetic order. Okay, also these ligands we have to name before central metal atom. Okay, the previous one when you are writing formula we have to write central metal atom first, then ligands. Okay, from formula you have to write name. So first ligands, then central metal atom. First we have to name ligands, then we have to name central metal atom or central metal ion. Clear? Okay, so this is second one. Next one here, name of anion. Name of anionic ligands end with O. Name of anionic ligands. For example, see here, chlorine. Chlorine, it is anionic ligand, and chlorine it named like chlorido. Chlorido. Bromine, bromido. Okay, iodo. And here CN, cyano. Okay, so anionic ligands, its name end with letter O. Cyano, chlorido, okay, bromido, etc. And here neutral and cationic ligands are named same like this. There is no change. Okay, neutral ligands and cationic ligands, ligands with positive charge, they will name their name same like that, same like the name of species. There is no change, but there is some exception case. Look here, NH3, H2O, CO, NO, these are neutral species. Okay, but their name different. Okay, when you are giving name for this ligands, NH3, its name amine, NH3 amine, H2O aqua, H2O aqua, CO carbonyl, CO carbonyl. Okay, CO, its name coming like carbonyl, carbonyl. And here NO, the last one, NO, it will be nitrosyl, nitrosyl. So here name of ligands, anionic ligands, it name end with the letter O. Okay, chlorido, cyano, etc. But ligands with positive charge or neutral ligands name same like their species name. But there is exception case, NH3 amine, H2O aqua. Okay, then we discuss CO carbonyl, CO carbonyl, NO nitrosyl. Okay, so name of ligands we have to give according to this order. Clear? And here this name of this ligands we have to use, we will include with a square bracket. Okay, and here another one here, the number of ligands we have to mention with this prefix di, tri, tetra, etc. Okay, so here prefix mono, di, tri, etc. are used to represent number of ligands. Clear? So see here, this is one coordination compound. So here two ligands, so you can use di. Okay, so here you have to remember prefix mono, di, tetra are used to represent number of ligands. Also there is one exception case, ligands with numerical prefix. Ligands with numerical prefix we will use bis, tris, tetrakis, etc. Here we used mono, mono mean one, di, tri. Okay, these are the prefix used to represent number of ligands. Okay, so here we can use dichloro or dichlorido. Okay, triamine, we can use like this, but sometime we will use bis, tris, tetrakis. Okay, bis mean 2. Okay, tris mean 3, tetrakis mean 4. This prefix bis, tris, tetrakis means 2, 3, 4. Okay, this type of prefix we will use ligands with numerical prefix. Okay, ligands with the numerical prefix, example see here, triphenyl phosphate. Okay, PPH3. This type of ligands, it is numerical prefix. Okay, if there is this type of ligands PPH3, here we will not say di, we will not use the prefix di. Here we will use bis triphenyl phosphate. Okay, bis triphenyl phosphate. Bis means this triphenyl phosphate coming 2 times, that is bis. Okay, so also we will discuss more example for coordination, more example for ligands with the numerical prefix. So now you understand ligands with this type of ligands are example for numerical prefix. Clear? And here last one, here one more one, oxidation state of central metal atom. Okay, oxidation state of central metal atom represent using Roman letter. Okay, for example here nickel. Okay, imagine nickel, its charge is nickel, its oxidation state 1. Okay, so here nickel its oxidation state 1. Imagine, so we will use Roman letter 1, and this Roman letter 1 will be included in a curved bracket. Okay, so this is the way to write oxidation state of central metal atom or central metal ion. So here we discuss some rules to name coordination compound. No need to memorize these rules, you just understand here what are the rules. Okay, so here cations are named first. Imagine you have to name a coordination compound, it contains cationic part and anionic part, so you have to name cationic part first. Okay, second one, ligands are named according to alphabetic order, then we have to name central metal atom. Okay, here when we are writing the formula of central metal atom, we have to write central metal atom first in the formula, but in name central metal atom coming at the end. Okay, also this central metal atom, there will be some oxidation state. Okay, oxidation state means charge of central metal atom. This charge of central metal atom we will represent using Roman letter. Okay, Roman letter, and this Roman letter oxidation state will be included in a curved bracket. Clear? And here ligands, negatively charged ligands, their name ends with letter O. Okay, and cationic ligands with positive charge or neutral ligands, their name same like their species name. But there is exception case, H2O aqua, NH3 amine, CO carbonyl, and another one nitrosyl, NO nitrosyl. Okay, after that we discuss here mono, di, tri, this type of prefix used to represent number of ligands. Okay, if there is numerical prefix, if there is ligands with the numerical prefix, we will use bis, tris, tetrakis, etc. Okay, so these are the rules we have to follow to name the coordination compound. Okay, to name coordination compound, we have to remember two more things. Okay, check here if our coordination compound contain cationic part and anionic part. Okay, so this cationic part, complex ion with the cation. Okay, imagine a coordination compound which contain cationic part and anionic part. Cationic part and anionic part. Okay, so I will give you example for this. Okay, so you just check here a coordination compound. It contain two coordination sphere. This is one coordination sphere, this is another coordination sphere. Okay, this is positively charged part and this is negatively charged part. Okay, and here there is one metal and ligands. Here also metal and ligand. So here coordination compound which contain a complex ion, and here the name of this metal is named according to the name of element. Example, imagine here this is one coordination compound, this is positive part, there is cobalt. So we will name this metal same like cobalt or nickel, okay, or platinum. We will name accordingly. But here metal or central metal atom in negatively charged part, complex ion with negatively charged part. Here this metal, name of this metal end with ATE. Complex ion, coordination compound, there is positively charged part and negatively charged part. Both coordination sphere there is metal. Name of metal in negatively charged part, this name of this metal end with ATE. Look here, example, cobalt. We know cobalt. If there is cobalt, we will just write cobalt. But if there is cobalt, we have to write cobaltate. Cobalt, after cobalt, it ends with ATE, cobaltate. And here you have iron. In this coordination sphere, you have iron. Iron, we know it is ferrum. Okay, so here name of this metal end with ferrate. Okay, ferrate, cobaltate, nickelate, platinate. Okay, it end with ATE. Next one we have to discuss here. I will give you some name of ligands and we will discuss how to write its formula. And we have some formula. From the formula we have to write their name. Okay, so till this we discussed rules to name coordination complex or rules to write formula of coordination compound. Okay, so all this you have to remember. Based on this information we have to solve the problems. Clear? Okay, so here we discuss rules for writing formula. Also we discuss rules for writing name of coordination compound. Based on these rules we have some example here. Okay, so let us check here different example. Look here, you have different structures, you have different formula of coordination compound. You have different formula for coordination compound. Based on this formula, let us check how we will get this name. Okay, so look here, this is the first example here CO. Okay, so here basically you have to understand ligands such as CO, NH3, H2O, ethylene diamine, they have no charge. Their charge is 0. Okay, carbonyl, CO mean carbonyl, NH3 amine, H2O aqua, EN ethylene diamine. This type of ligands, their charge 0. Okay, remember this, they have charge 0. So let us we have to name this one. So here 4 carbonyl. So here tetracarbonyl nickel. Tetracarbonyl nickel. Okay, that is written here, tetracarbonyl nickel. And here nickel, the charge of nickel or oxidation state of nickel here 0. Okay, look here how we will get the oxidation state of nickel. We want to find oxidation state of nickel, so it is unknown. Okay, so put any letter over here, then 4 times look here CO. I told you before, carbonyl, their charge 0, carbonyl 0. So 4 times 0 equal, here no charge, here outside this square bracket there is no any particular charge, so it will be 0. Fourth, so y plus 4 times 0 equal to 0. So charge of nickel 0. Look here, this y mean it is unknown value. You can put any letter over here, x or y, any letter you can use. Okay, so y equal to 0. So oxidation state of nickel here 0. Okay, so name of this coordination compound tetracarbonyl nickel 0. Okay. Here second example here. Look here, we have here amine and aqua. Amine and aqua. Okay. So you have to understand this is coordination sphere. Okay, this will be here there is cation part and there is anion part. The previous case it is neutral ligand. Okay, there is no any charge. It is neutral ligand. But here second one you have here positive part and negative part. Clear? So to name this one, we have to find the charge. We have to find the oxidation state of chromium. Okay, so chromium, we have to find oxidation state. Chromium, it is unknown, so put any letter here. Okay, chromium. And I told you before, NH3 and H2O, their oxidation state will be 0. 3 times 0 plus 3 times 0, it will be 0. Okay. And see here, here there is cation part and here anion part. We know chlorine, it is minus 1. Okay. So minus 1 times 3. So this anion part will be minus 3. So here cation part will be plus 3. You understand? So this coordination compound, there is two part, positive part and negative part. Negative part, it will be minus 3. Okay, we discussed the rules to name rules. Coordination compound which contain cationic part and anionic part. Coordination compound which contain positive part and negative part. So the magnitude of positive and negative charge will be equal. Okay, we discussed already. So here this negatively charged part minus 3 because 1 chlorine minus 1. 3 chlorine here, 3 times minus 1, so minus 3. So negatively charged part minus 3. So positively charged part will be plus 3. Minus 3 plus 3. So it will be cancel each other. Clear? So here chromium, we want to find oxidation state. It is unknown. Y plus 0 equal plus 3. Equal plus 3. Why it is plus 3? Because here this coordination sphere, it is cationic part. Its charge plus 3. So y equal to plus 3. Y equal to plus 3. So oxidation state of chromium here. Oxidation state of chromium here 3. Okay, we discussed 3. We will use Roman letter to represent oxidation state of metal. So look here two ligands here, amine and aqua. Okay, so we have to arrange them according to alphabetic order. Amine first, then aqua. Okay, so here triamine, triaqua, chromium 3 chloride. So this is cationic part, this is anionic part. We will say always cationic part first. Okay, triamine, triaqua, chromium 3 chloride. Look here, triamine, triaqua, chromium 3 chloride. There is no space between ligands, transition metals, anything. Okay, without any space, without any capital letter between, you have to write their name. Clear? So here this Cl3, we will write here chloride. No need to write trichloride, you just write chloride. Clear? This is the name of second coordination compound. Let us check here third one. Third one, it is cationic part only. Here already given 2 plus. There is no anionic part. So it is ion. Okay. We know positively or negatively charged species. They are ions. So this is ions. So hexa aqua manganese. Hexa aqua manganese. Okay. This is written here, hexa aqua manganese. Okay, let us check how to get oxidation state of manganese. We want to find oxidation state of manganese. So we can use one letter to represent manganese. Okay, and here hexa aqua. Oxidation state of water 0, even 6 water molecule, 3 water molecule. Okay, so here 6 times 0, so it will be 0, equal here already given plus 2. Okay, so Y equal to plus 2. So oxidation state of manganese 2. So here hexa aqua manganese 2 ion. We have to write here ion. Why here ion? Because it is charged species. So we have to write here ion. Okay. In previous case there is no ions because here it was like this. Okay, there is negatively charged part and positively charged part. So their charges will be cancel each other. So it will be neutral molecule. This is also neutral molecule. Only this one here charged species. So it will be ion. Look here, another example here. Here 3 ligands, amine, chlorido, nitrito N. Look here you have to remember, look, we discussed ambidentate ligands. Okay, so NO2, ONO, NO2, ONO. These are ambidentate ligands. They have same molecular formula, 1 nitrogen, 2 oxygen in both case. Okay, NO2 mean here nitrogen make linkage with the central metal atom. Okay, and ONO mean here oxygen make linkage with central metal atom. They are ambidentate ligands. Okay, same molecular species but different atoms make linkage with the central metal atom. That is ambidentate ligand. So here NO2 mean we have to write its name nitrito N. You have to write its name nitrito N. Nitrito N mean here NO2 nitrogen making bond with the central metal atom. If there is ONO, we will write like this nitrito O. Nitrito O mean here also NO2, nitrogen and 2 oxygen atom, but oxygen make linkage with the central metal atom. Remember this, NO2 and ONO, nitrito N, nitrito O. Clear? So look here. To name this one, diamine, chlorido, nitrito N. Okay. Diamine, chlorido, nitrito N, platinum. Its name coming like this. Diamine, chlorido, nitrito N, platinum. Platinum. Here it is written platinum 2. So let us check how its charge coming. Here platinum, we want to find its charge. So here it is unknown value. So put Y, letter Y. Okay, plus amine, it is 0. Chlorine, we know halogens. Fluorine, chlorine, bromine, iodine, all these halogens, they have -1. Here I told you these groups, their charge 0. Okay, similarly you remember all halogens, F minus, Cl minus, Br minus, I minus, these are halogens, they have -1, their charge -1. Okay, so here chlorine -1, Nitrito, NO2 and ONO, their charge will be -1. Okay, and here square bracket outside no charge, it's mean 0. Okay, so here y -1, so y will be +2. Okay, so y -1, so y -2 equal to 0, so y equal to +2. That's why here platinum 2. Clear? So here name of this coordination compound diamine chlorido nitrito O platinum 2. This is the name of this coordination compound. Clear? Here last example. Look here, to name this one we have here two parts. Here potassium. This is positively charged part and this one negatively charged part. Okay, this is positively charged part and this is negatively charged part of coordination compound. So to name this type of coordination compound, we discuss coordination compound which contain positively charged part and negatively charged part. Metal present in positively charged part, we will say its name. Metals in positively charged part, we will say its name, same like that. Here potassium. Okay, also metals present in negatively charged part of coordination compound, we will say its name, name of this metal end with the ATE. We discussed metals present in negatively charged part, cobaltate, ferrate, we discussed already. Similarly here metal in negatively charged part, so it will be zinc, zincate, ATE. Okay, zinc, its end, name of this metal end with the ATE. Okay, so you have to remember this. So look here, to name this coordination compound potassium tetrahydroxozincate. Okay, potassium tetrahydroxo, OH hydroxo. Also you remember OH minus, negatively charged ligands, their name end with O. Chlorido, bromido, iodo, hydroxo, cyano. Okay, CN minus, cyano. All this have -1 charge. OH minus, CN minus, they have -1 charge. Clear? So here potassium tetrahydroxozincate. Clear? Potassium tetrahydroxozincate. Zincate, the charge of zinc here 2. Let us check here how the charge of zinc getting 2. Look here, we want to find the charge of zinc here. Okay, here potassium, it is group 1. In periodic table, we know potassium in group 1, lithium, sodium, potassium, rubidium, cesium. Group 1 elements, they have +1 oxidation state. Group 2, +2 oxidation state. But here zinc, it is transition metals. We cannot predict its oxidation state. They have variable oxidation state. Okay, so here potassium, it is group 1. There its charge +1. And how many potassium here? 2 potassium. +1 times 2 plus. Here zinc, it is unknown. We have to find its charge. Okay. Then OH minus mean -1. How many OH here? 4. So -1 times 4. -1 times 4 equal. Look here, outside the square bracket there is no any number, so it is totally, it is neutral ligands, neutral coordination compound, so it will be 0. So +1 times 2 plus y plus -1 times 4. Okay, so you can say here 1 times 2 mean it is 2. 2 plus y minus 4 equals 0. Okay, 2 plus y minus 4 equals 0. So y will be 2. Okay, this will be Y equal to plus 2. So here oxidation state of zinc is 2. So here to name this one, I will repeat once again: potassium tetrahydroxyl zincate 2. Okay, here zincate, because zinc coming in negatively charged part of coordination compound, that's why zincate. Clear? Okay, let us check here few more examples how to write name of coordination complex. Look here first one, cobalt En twice SO4 twice. So this is one coordination compound. This coordination entity repeating twice, then SO4 twice. Okay, this compound like some ionic compound like this Mg3N2. Here magnesium 3 times, nitrogen twice. Okay, how these 3 and 2 coming? We know magnesium 2 plus and N 3 minus. So after cross multiplication, it will be Mg3N2. Clear? So this 2 coming from here, this 3 coming from here. Clear? So similarly here when you consider this one ionic compound, this 3 coming from here and this 2 over here, SO4 2 minus. Clear? So to name this compound, look here En mean it is diamine, CH2, each end there will be NH2. Okay, its short form we can write En. Okay, so name of this one, look here, this is one organic compound 1,2. We can name this compound like this: ethane 1,2-diamine. Ethane 1,2-diamine. Clear? So here ethane 1,2-diamine. So how to name this compound now? Look here ethane 1,2-diamine, it coming 3 times. So this type of ligands we will not use. Mono, di, tri. We will use bis, tris, tetrakis, etc. Okay, so here ethylene diamine. Also we have another type of ligand. See here PPH3. Here it is 2. So this type of ligands we will use bis, tris, tetrakis, etc. Okay, so here we have En twice, En repeating 3 times. So tris ethane 1,2-diamine. Here En mean it is ethane 1,2-diamine, that is En. So tris ethane 1,2-diamine, cobalt its charge is 3, cobalt 3 sulfate. This is the name of this compound. I will tell you how the charge of cobalt 3. Now you understand. Name of this coordination compound: tris ethane 1,2-diamine, cobalt 3 sulfate. Here no need to write trisulfate. I told you before, this anion part you just write sulfate, chloride, bromide. Okay, even there is one bromine or one chloride, okay, you just no need to mention mono, di, tri. Okay, now let us check here why cobalt is 3. Here we want to find the oxidation state of cobalt, so it is Y. Okay, ethylene diamine, it is neutral ligand. It is neutral ligand. I told you before, NH3, H2O, CO, En, these are neutral ligand. Okay, so it is neutral ligand. Okay, equal to plus 3. I told you before, here this coordination compound just like ionic compound Mg3N2, this 3 from here, this 2 from here. Similarly, this coordination compound, this 3 from here, 3 plus, this 2 from here, 2 minus. So this coordination entity, its overall charge plus 3. So Y equal to plus 3. So here oxidation state of cobalt, it is 3. So name of this coordination compound, tris ethane 1,2-diamine cobalt 3 sulfate. Clear? Okay, let us check next example here. Next example, here you have positively charged part and negatively charged part. Here sodium, this is positively charged part and these are the negatively charged part. These are the negatively charged part of coordination compound. Okay, so here positively charged part metal, we will say its name same like its element name sodium. Metal present in negatively charged part, we have to add ATE, platinum, platinate. Okay, so here sodium, here you have different ligands, bromido, chlorido, nitrito and amine. So you have to arrange alphabetic order. So amine coming first, amine, alphabet A. So amine, bromido, chlorido, nitrito N. Okay, so here sodium, amine, bromido, chlorido, nitrito N, platinate. Okay, so here name of this coordination compound sodium, amine, bromido, chlorido, nitrito N, platinate. This N you have to use capital letter, nitrito N, platinate 2. So here platinum, its charge is 2. Let us check how the charge of platinum 2. Look here sodium it is plus 1, group 1. So sodium it is plus 1, okay, and platinum it is unknown, and bromine minus 1, chlorine minus 1, NO2 minus 1, NH3 0. Okay, here sodium plus 1, this is unknown, minus 1, minus 1, minus 1, 0. That is written here. So when you solve this, y equal to y minus 2 equal to 0. So y equal to 2. So platinum 2. Sodium, amine, bromido, chlorido, nitrito N, platinate 2. This is the name of this coordination compound. Clear? Here third example, here we have another one. Here cobalt, okay, here bromido, again here ethane 1,2-diamine chloride. So to name this one, let us check here. We have to arrange ligands according to alphabetic order. So here Br2, 2-bromine, dibromido, tris ethane 1,2-diamine cobalt chloride. Okay, cobalt 3 chloride. Name of this compound once again. Look here, dibromido, tris ethane 1,2-diamine cobalt 3 chloride. Okay, here bromido, ethane 1,2-diamine, tris ethane 1,2-diamine. So here it is ethane, it is bromido. So alphabetic order, this is coming first. Here 2-bromine, dibromido. Okay, this type of ligands we will not use tri, we had to say tris ethane 1,2-diamine. So name of this compound dibromido, tris ethane 1,2-diamine cobalt 3 chloride. Okay, here cobalt, we want to find its oxidation state of cobalt, unknown, Y. Okay, 2-bromine. So here 2 times minus 1 plus 0 equal. Look here cation part and anion part. Chlorine, it is minus 1. And this part will be positive 1, plus 1. Because I told you before, positive part and negative part will be cancel each other always. So here Cl minus. So this coordination entity to always plus 1. Okay, here Cl minus, so it will be, this part will be plus 1. So you have to say equal to plus 1. Why here equal to plus 1? Because here plus. Okay, why here plus? Cl minus, here minus 1, so it will be plus 1. Positive part and negative part will be cancel each other. So here y minus 1 times 2 plus 0 equal to plus 1. Okay, so y minus 2 equal to plus 1. So y equal to plus 3. Y will be plus 3. That's why here cobalt 3. Okay. Here last example, here two more example here. Let us check here. See here, this is one different coordination compound. Here AgNH3 twice, AgCN twice. Okay, here two coordination entity. If there is two coordination entity, first one positively charged part, second one negatively charged part. Okay, here overall charge will be 0. Overall charge 0. So here this is, you can say this is plus 1, this is minus 1. First part it will be positive part, second part it will be negatively charged part, and the positive part and negative part together it will be 0. Clear? So you have to say this is plus 1 and this is minus 1. Clear? Now see here, to name this one diamine silver. Also look here, metal present in positively charged part and negatively charged part. Metal present in positively charged part, it will be its name of its element, silver. Okay, here name of this metal we have to mention silver, because this Ag in positively charged part, and here also metal silver in negatively charged part. So we had to add Ate at the end. Okay, metal in negatively charged part, we had to add Ate. Okay, so here Ate, but we have silver after silver Ate, not like this. Okay, we know silver, it's another name argentum. Okay, so argentum, so we have to add Ate after that. Argentate, not silverate. We will not say like that. We have to say argentate. Okay, actually if sometime in some coordination compound you can see iron. So iron in positively charged part we will say iron. Iron in negatively charged part we have to say ferrate. Ferrate, not ironate. We have to say ferrate. Similarly here silver and here argentate. Okay, so look here diamine silver, dicyano argentate. Its name coming like this, diamine silver, dicyano argentate. Clear? Diamine silver, dicyano argentate. Now let us check here. Here silver 1, here also argentate 1. Both case it getting plus 1 oxidation state. Let us check how this. Look here. Here I told you this coordination entity total charge will be 0. So imagine this is plus 1 and this is minus 1, because total charge 0. We know amine it's charge 0. Okay, here NH3 it's charge 0. So y plus 0 equal to plus 1. Here this coordination entity there is plus 1. So we have to say y plus 0 equal to plus 1. So y equal to plus 1. So here silver plus 1 oxidation state. Similarly here, look here, AgCN twice. Cn, cyano, I told you before, Cn minus, OH minus, their charge minus 1. Cn minus, OH minus, halogens, they have minus 1 oxidation state. So here Ag, Cn twice. Okay, so Ag it is unknown, Cn it is minus 1. Okay, Cn it is minus 1 times 2 because 2Cn equal to minus 1. Here equal to minus 1. Now see here y. Now see here I am writing this here y minus 2 equal to minus 1. Y minus 2 equal to minus 1. Y minus 2, here Cn it is minus 1. 2 times minus 1 it is minus 2. Here it is minus 1. That's why equal to minus 1. So when you solve this, when you bring minus 2 right hand side, it will be plus 2. So you will get y equal to plus 1. That's why both case here silver getting plus 1 oxidation state. Okay, so diamine silver 1, dicyano argentate 1. Okay, this is the name of this coordination compound. Clear? Here last example here we have different ligand here PPH3 twice. Okay, so we know this is triphenyl phosphate. Okay, and here 2, this 2 will represent bis. Okay, I told you here En tries this type of ligands we will use prefix bis. Okay, so look here, you have to arrange this ligands also according to alphabetic order. So here dichlorido bis triphenyl phosphate nickel, its name coming like this. Okay, here it will be dichlorido bis triphenyl phosphate nickel 2. Okay, nickel 2. Why here nickel 2? Here also you have to remember PPH3 triphenyl phosphate, its charge also 0. Okay, so here nickel, you want to find the oxidation state of nickel. It is unknown. Why? Chlorine, it is minus 1. Here 2 chlorine, so twice 2 plus 0 equal to, this is coordination sphere, there is no particular charge, so equal to 0. So minus 1 times 2, it will be y minus 2 equals 0. So y equal to plus 2. So here nickel will be plus 2 oxidation state. Clear? So name of this one dichlorido bis triphenyl phosphate nickel 2. This is the name of coordination compound. Okay, dichlorido bis triphenyl phosphate nickel 2. Clear? Okay, next one we have to discuss here. We have given name of coordination compound and we have to write its formula. Okay, so look here, we have different names. We have to get these formulas. So let us check how this formulas getting. Okay, so here first example, iron 3 hexacyanoferrate. Iron hexacyanoferrate. Okay, so look here, iron and hexacyanoferrate. So here it is given iron 3. The first one iron, its oxidation state plus 3, and hexacyanoferrate. Here iron it is plus 2 oxidation state. It is this also given in hexacyanoferrate iron it is plus 2 oxidation state. And Cn it is minus 1 and here 6Cn, so minus 6. So plus 2 minus 6. So overall charge of this part it will be minus 4. Okay, so here you have Fe, you have here Fe and FeCN6. Okay, and here look here, here it is plus 3 and here it is minus 4. So after cross multiplication, this 4 will be over here, this 3 will be here. Okay, so that's why the formula like this. Fe Fe4 FeCN6 twice. Clear? So I will repeat once again here. You have iron 3 hexacyanoferrate. Iron 3. So here this is iron hexacyanoferrate. Iron 3. Iron, its oxidation state already given. It is +3. And hexacyanoferrate here the oxidation state of iron, it is given +2. Cn -1. Okay, -6. Here 6Cn, so -6. +2 -6, it will be -4. So iron, it is +3. This part overall charge -4. Okay, here it is +3. Here it will be -4. So after cross multiplication, it will be Fe4 FeCN6 twice. That's why the formula like this, Fe4 FeCN6 twice. Clear? So this is the formula of first coordination compound. Look here, next one, second one. Tetraamine diaqua cobalt 3 chloride. Okay, tetraamine. So simply you can write here tetraamine. Tetraamine. You have to, we learned the rules. First we have to write cobalt, transition metal. Then we have to arrange ligands according to alphabetic order. We learned already these rules. Okay, so cobalt, tetraamine, okay, diaqua. So we have to arrange ligands and central metal atom accordingly. Then chloride. Chloride means there is many possibilities, Cl minus, Cl2, Cl3. So here it is Cl3. Let us check why here Cl3. Okay, so here cobalt NH3 H2O. We know H2O is charge 0, NH3 is charge 0. Here in the name it is given cobalt 3. Cobalt 3 means oxidation state of cobalt, it is +3. Okay, so here the overall charge of this coordination compound, this coordination entity, it will be +3. Cobalt, it is +3, 0, 0. So the overall charge will be +3. Okay, so the positive part, it is +3. We know positive part and negative part, the magnitude of charge will be equal and they will cancel each other. So here, you know, Cl, it is -1. Okay, so we have to get it is -3 because here +3. So this also -3. So chlorine, it is -1. So it must be 3 chlorine. Then only it will be -3. So here cobalt NH3 4 times, H2O twice. Okay, Cl3. This is the charge. Okay, here overall charge +3. That's why here Cl3. In the formula, no need to write here +3. Okay, this is the formula of this compound. Clear? Here last example here, potassium tetracyanonickelate. Potassium tetracyanonickelate. So there is potassium tetracyanonickelate. Nickelate, its charge is given 0. Okay, so here this part tetracyanonickelate, its charge is given 0. The charge of nickel 0. Cn, I told you before, Cn, it is -1, 4 Cn, so -4. So overall charge of this part, overall charge, here 0, here -1. So overall charge here, it will be -4. Okay, and potassium, it is group 1. Okay, it is group 1 in periodic table, so it will be +1. Clear? So when you are writing this formula, potassium tetracyanonickelate, you have to do cross multiplication. This 1 will be here and this 4, -4, this 4 will be over here. So K4 nickel tetracyanonickelate. Okay. So here it will be K4 and here it will be 1. 1, no need to write it. Okay, 1 no need to write. So this is the formula of this coordination compound. Potassium tetracyanonickelate, potassium, okay, nickel, here its charge given 0, okay, Cn minus 1, here 4Cn, so minus 4, so overall charge it will be minus 4, potassium it is plus 1, after cross multiplication K4 and this part will be 1, no need to write it, so the formula coming like this, clear? Okay, we have few more example here. Okay, so here next one, hexa aqua manganese 2 ion, hexa aqua manganese 2. So hexa aqua mean 6 water molecule, okay, manganese. So we know manganese first, we have to write manganese first, then hexa aqua. Okay, and see here water molecule its charge 0 and here it will be plus 2 because here it is given 2. Okay, so the overall charge it will be here it will be plus 2 because it is ion. Okay, MnH2O 6 time square bracket it is plus 2. Okay, so coordination compound with charge, clear? So this is the name of this coordination compound, hexa aqua manganese 2 ion. Next one we have chloro bis ethylene diamine. We discussed before EN, ethane 1,2-diamine, ethane 1,2-diamine, or you can say ethylene diamine, ethylene diamine. I told you before CH2 CH2 NH2 NH2. Okay, so here ethylene 1,2-diamine or ethylene diamine represented by En. It is bis ethylene diamine. So ethylene diamine coming 2 times and there is chlorido. Chlorido mean 1 chlorine, ethylene diamine twice. Also there is nitrito-O. Nitrito N mean NO2. Nitrito O mean ONO, cobalt 3. So cobalt here it is plus 3 oxidation state and chlorine minus 1, ethylene diamine 0 and NO2 or ONO minus 1. Okay, so here plus 3 minus 1 minus 1. So when you cancel this all, the overall charge will be plus 1. So this coordination compound they have plus 1 charge. There will be a plus 1, positive 1 charge. Okay, and see here chlorido ethylene diamine. There is chlorido ethylene diamine nitrito. Okay, there are 3 different ligands. You have to arrange them according to alphabetic order. Chlorido ethylene diamine nitrito. So same order coming here. Central metal atom first. Here overall charge plus 1. So this is the structure or this is the formula of this coordination compound. Clear? Here last example, triphenylphosphine. Triphenylphosphine. This is triphenylphosphine. We discussed before PPH3. PPH3. This is triphenylphosphine. Phenyl mean you know phenyl. C6H5 benzene ring. Okay, that is phenyl group. Okay, so C6H5 this coming twice, then phosphorus. Okay, C6H5 twice, then phosphorus. This is triphenylphosphine. Triphenylphosphine. Clear? So triphenylphosphine. This triphenylphosphine it coming triphenylphosphine it will be tris. This coming 3 times. Okay, tris triphenylphosphine, rhodium 1 chloride. Rhodium RH. This is rhodium plus 1 oxidation state. Triphenylphosphine 0 oxidation state. Okay, so these are the things in coordination sphere, coordination entity. Chloride, it is not ligand. If it is ligand, we will say chlorido. It is not chlorido, it is chloride. Chloride means it is anion, it coming outside the coordination entity. Okay, chloride. So there is many possibility, maybe Cl, Cl2, Cl3. So here we choose Cl. Why here Cl? That's we are discussing here. Why here Cl, not Cl2, Cl3? So look here, RH it is +1. This triphenyl phosphine it is 0. So overall charge it will be +1. Okay, so positively charged part it is +1. So negatively charged part also same -1. Positive part and negative part will be cancel each other. Here +1, so there will be 1 chlorine. If you are +2, there will be 2 chlorine. If you are +3, there will be 3 chlorine. Okay, so here the overall charge +1. So this is the formula of triphenyl phosphine rhodium 1 chloride. Clear? So these are the things we have to discuss in this video. This video already getting longer. So isomerism in coordination compounds we will make another video. Okay, so you can watch next video. So thank you for watching this channel.